In this lecture, we'll see the next boosting algorithm, that is the gradient boosting, which is also named as the GBM. So gradient boosting or the GBM is another ensemble machine learning algorithm that works for both the regression and for the classification. So it uses the boosting technique. It combining a number of weak learners to form a strong learner. So regression tree is used as a base learner. Each subsequent trees is in the series is built on the errors calculated by the previous trees. The same strategy here used as the boosting technique. Okay, so what is the difference over here by using this algorithm that we will see? So for that we are considering one example to understand the GPM algorithm. So we have to predict the age of the group of people using the below data. So group of people ki age we have to find out from the given data. So this is the data set given, which has 5 features and 5 data samples. So age is considered as the target variable. So first step that we have to do is the mean age is assumed to be predicted values and for all observation in the data set. Okay, so predicted value means the target age we have to consider. So mean age is assumed as this target age. Okay, so now we have to calculate in next step the error using this mean prediction and the actual values of age. So this can be done. A tree model is created using the errors calculated above as the target variable. Our objective is to find the best split to minimize the error, right? So we have to minimize the errors. That is our objective. So the prediction by this model are combined with the prediction 1. Okay, so the prediction of the model is over here, age of the target variable, which is given over here. That is 3524. That is now in next step the mean prediction values for each and every data samples we have to consider. That we have considered suppose 32. Okay, now from this we have calculated the new targets, that is the subtraction of this. Okay, so here we have calculated that residue 2, that is the new targets of that particular data, right? Okay, now same step we are repeating till the maximum number of iteration is reached or error function does not change. So here we can see the errors we are getting, that is 3 minus 8 6 minus 2 1. So this we have to reduce. So that's why we are considering the next prediction as this one. Now combining this mean and the next prediction, that we are getting this value, right? Now if we calculate the residual 2 with the latest target, so what it will be if you compare with the base one? So 35 means no error, 27 means minus 3, 35 means minus 3, 27 means minus 3. So likewise we have to combine. Okay, so and we have to choose the best learner and number of iterations. Likewise we have to repeat this step till the maximum number of iteration is reached and error function does not get changed. तब तक हमें ये repeat करना है same steps. Okay, so from sklearn we are importing that gradient boosting classifier model and we are considering the error rate as 0.01 and random state 1, and we are applying that model on the training data set and we are calculating the score on the testing data set. So that will be 81.62. So there are certain parameters over here also that will be considered, that is minimum sample split, how much minimum samples required, and how much. Next is the mean sample slip. It will define the minimum samples required in a terminal or the diff node. Minimum weight fraction lift, it will find out the fraction of the total number of observation instead of an integer. Maximum depth of the tree, it will be defined by the max depth. Max leaf nodes कितने होने चाहिए, that will be decided by the max leaf node. And maximum features in कितने होने चाहिए to find out the best split, it will be defined by the max feature. So this is all about the gradient boosting. In next lecture we will see the next concept, that is clustering fundamentals. So we are going to